Given that g of x equals x squared plus 4 over x minus 2, find the limit as x approaches 2 of g of x. The function is a quotient of two functions, so let's use our quotient property. Remember that when we use the quotient property, we take the limit of the top and divide it by the limit of the bottom function. X squared plus 4 is a polynomial, so that means we can evaluate this limit using direct substitution. X minus 2 is also a polynomial, so we can evaluate this limit using direct substitution. Now let's simplify. We get 8 in the numerator and 0 in the denominator. Remember that our denominator can never be 0, because if it is, it means the function is undefined at that value. So because we substituted 2 and we got 0 at the bottom, that means the function is undefined at 2. So now we need to come up with another way to find this limit. If you have a rational function and then you substitute the value and get 0 in the denominator, factor the top and the bottom to see if any factors cancel out, and then try the direct substitution again. X squared plus 4 does not factor, so we can't compute this limit by factoring. Let's try to compute this limit by using a table. We want to compute the limit as x approaches 2, so we will put 2 in the middle. Then we will find some values close to 2 to the left of 2. And then we will find some values to the right of 2. Let's find the function value at 1.9. To find this value, just substitute 1.9 in for x everywhere in the function. Type this in your calculator and we get negative 76.1. So now let's write this value on the table. Now do the same to all the values to the left of 2. When we substitute 1.99, we get negative 796. And when we substitute 1.999, we get negative 7,996. Now let's do the same to the values to the right of 2. When we substitute 2.1, we get 84.1. When we substitute 2.01, we get 804.01. When we substitute 2.001, we get 8,004. Now let's interpret the values on the table. When computing limits using a table, you want to see what the behavior is of the function values as x gets close to 2. So we look at the behavior to the left of 2, and we look at the behavior to the right of 2. So as we approach 2 from the left, what's happening? We have negative 76, negative 796, negative 7,996. These values are getting smaller and smaller. And as we approach 2 from the right, we have 84.1, 804.01, 8,004. These values are getting larger and larger. So remember that whenever we have a limit, we need to be approaching a certain value, a certain number. Here, we're not approaching any value. The values from the left are just getting smaller and smaller, and the values on the right are just getting larger and larger. So because we're not approaching any specific number, we say that the limit does not exist. You can abbreviate this with DNE. So we found that the limit does not exist using a table. Now let's use a graph. We are computing the limit as x approaches 2, so let's identify the x value 2 on the graph. 2 is here. Now let's look at the behavior from the left of 2. Notice that the graph just keeps decreasing without bound, coming in from the left of 2. Now let's look at the behavior to the right of 2. The values just keep growing to the right of 2. So because we're not approaching a number, we say that the limit does not exist.